Hi everyone, this is your lab demo. Today we'll be working with confidence intervals, and we'll be working with three types. Under the stat menu, we'll be using the proportion stats, t-stats, and variance stats menu items. We'll start with proportion stats. We're in 9.1 here, and we're just doing one sample confidence intervals. Now, sometimes you'll have raw data and sometimes you'll have summary data. In 9.1 and 9.2 today, with these problems, we'll be using summary. In 9.3, you'll be using raw data. And so the first thing we need to do is open up proportion stats, one sample with summary, so that I can demonstrate some of those features. Now what you have to do here is input number of observations and number of successes. Successes would be X, observations would be N, and then we'll click confidence interval and put in the level of confidence. I'm going to be using number 26 in 9.1. You'll be working with number 25, so my numbers will be a little bit different. In number 26, we have a retirement confidence survey of 1,153 workers and retirees in the United States, 25 years of age and older, was conducted, and the survey found that 496 had less than $10,000 in savings. So 496 would be number of successes. The N value, the number of trials, would be the total number of participants in the survey, 1,153. So we have 496 for number of successes, and we have 1,153 for the total number of trials. Now in this problem, we are asked to construct a 95% confidence interval. You notice here it's in decimal form, so we have 0.95. Also 90%, 80%, 99% are common levels of confidence. For this one, the default is 95. We'll leave it like that. And of course, remember decimal form. When we compute, we get a lower limit and upper limit, and we do get a sample proportion, which is the point estimate required for this problem. Now let's move on to the mean. When we work with confidence intervals for the population mean, we'll be using, on the stat menu, t-stats. Now again, we're working with a single sample and we have summary data. I'll be working with number 20 in 9.2, whereas you'll have number 19. Now we are given in number 20 a sample mean of 35.1. You notice we do need to input that. Sample standard deviation we are also given, which is 8.7. And the sample size. Now, we are given that in part A, we are asked to construct a 90% confidence interval for a sample size of 40. And so we'll put in 40 first, and confidence interval, and again 90%, so we'll switch this to 0.90 and compute. So we get our lower limit, upper limit, as well as, of course, our sample mean was already given. So now in this problem we are asked to also construct the same confidence interval at 90% for a different sample size of 100. So for this one, once you save your result, you can go ahead and edit in order to make changes to the sample size or the level of confidence. So for different parts of this problem, you'll be asked to change some of those input values, and then you'll click compute again and resave. So for the last problem, we'll be working with confidence intervals for the sample standard deviation and variance. The problem in 9.3 requires you to work with raw data. You will be opening the data from the MyStatLab website. You'll click on StatCrunch and then open datasets from the textbook. We are in Chapter 9, and the data will be, you will work with 9.3 number 15. I'll do the demo with 9.3 number 16. So you'll notice here I have the data open. The first thing we need to do is verify that the population is reasonably normal. We will use a QQ plot, also known as a normal probability plot, to determine whether we can assume the population is normal. We have a linear pattern, a high correlation statistic, and we can assume the population is normal, which means that we can go to variance stats, one sample with data, select the data set, and complete a confidence interval. And so what we will do here is select, now in this problem 95% confidence interval is requested, so we'll leave it at the default and compute. Now this is pretty much like any of the other problems, except notice here that one sample variance confidence interval. We are actually asked to compute a one sample standard deviation confidence interval. The standard deviation is the square root of the variance. So a sample standard deviation is the square root of the sample variance. The lower limit would be the square root of the given variance lower limit, and the upper limit the square root of the given variance upper limit. So don't forget, you do need, in order to get your answers for this problem, you need the square root of all three of these values. So don't forget to do that. That's the one trick here. Now the other thing I might note here is that if we go to stat variance stats one sample with summary, if you are given standard deviation information and variance is requested here in this test, you will need to square your standard deviation in order to put in a variance value. So it depends on what values you are given and what values are requested. StatCrunch always requests variance and it always outputs variance. So please make sure that you square or square root accordingly depending on what information you have to work with and what information you need as your output. If you have any other questions about this, please ask. This is the trickiest part of confidence intervals. So that should complete the demo for Lab 6. Please ask if you have any questions.